In this video, we are going to understand about graphs of kinematics, which is actually the part 2 of the chapter motion in one dimension. And if you have not watched the part 1 of the chapter, then you can click on the link given in the description box below. So let us start with the chapter graphs of kinematics. So there are three main types of graphs. First, S versus T graph or displacement versus time graph. Second, velocity time graph. And third, acceleration time graph. So these are the three graphs. Now we first need to understand the displacement time graph. Let us understand displacement time graph. So a displacement time graph looks like this. On the y-axis, we write the displacement covered by the body in meters, and on the x-axis we write the time taken by the body to cover that much of the distance in seconds. Here I have drawn a graph. Now let us analyze this graph. What this graph is trying to say to us in practical way. So here 10 meters of a distance is covered by a body in how much seconds? In 1 second. Here you can see, right? So what is this? For an example, I have a body Y, which is a ball, and it is covering the distance of 10 meters in 1 second. So here the distance of 20 meters is covered by the body in 2 seconds. Now here, if the body goes for another 10 meters, it will cover it in another 1 second. So same manner, 30 meters of distance is covered by the body in 3 seconds, 40 meters of the distance is covered by the body in 4 seconds, 50 meters of the distance is covered by the body in 5 seconds. So you can see a pattern here, and what is that pattern? Let me tell you. 70 meters of distance is covered by the body in 7 seconds, and in the same way 10 meters is covered in 1 second. So what can we tell here? We can tell the velocity of the body. How can we tell the velocity of the body? Simply by looking at the displacement time graph. So for that, you need to know the formula for velocity, and the formula for velocity is displacement upon time. And how this graph can help us finding the velocity of the body, let us understand. Here we have the displacement, here we have the time given to us, so we can easily find the velocity of the body at any given point. Yes, by simply dividing the displacement by time. For an example, if I take a point x here, and if I tell you to find the velocity of the body at point x, what will you do? You will divide 60 by 6, which will give you the answer 10 meters per second as your velocity. So this is our displacement time graph simply explained. So here once again revising the concept. So here we have the displacement, here we have the time, and when you divide displacement by time, you get the velocity at any given point on this graph. And this is the case for the uniform velocity. And what about non-uniform velocity? Let us see that. Here I have drawn a very tricky, very difficult and a type of graph which is usually asked in examination. This is a type of graph which is not as easy to understand as the previous graph which I showed you. So here we have the displacement, we have the time, but the graph is not directly going up. It is going up and then it is going down. What does this mean for the body? This means that whatever motion the body is carrying, which is of course the positive motion of the body, here you can see it starts from 0, which means some external force is applied on the body when it is on rest. some external force is applied on the body, when it is in rest, it then gains some motion, goes and covers up some distance, and then abruptly stops and goes back. And how can I say all this just by looking at the graph? Because it is a mere displacement time graph, and as you know, displacement is just the shortest distance which is covered by the body, and that is particularly in the straight line. It is very different from distance, and here the body is moving back because from this slope, which is a downward slope, we can understand that the body is having negative type of motion in respect to the positive slope which we saw here. And finally, the question arises, what is the practical situation of a body when a graph is made like this, a triangular graph? So here you can easily understand this by, for an example, if a man is throwing a ball towards the wall, the ball is hitting the wall and then it goes back. Here this is the wall and then the ball goes back. So this graph is as simple as that. Here the initial velocity, you can say here the body is starting from rest, and then you can assume that an external force is applied to the body, and then the graph rises, and as the graph rises it abruptly stops. Here you can assume that the ball is hitting the wall, and when the ball is hitting the wall, the graph goes down. And what is this graph? Displacement time graph. And from this we know that the body is moving in negative motion, or you can say in negative motion in respect to the positive graph which we just saw. So here this was all about displacement time graph. Displacement time graph, if you have understood till here, that means one third of your concept about this chapter is very clear now. You can solve any type of displacement time graph questions just by analyzing the motion of the body, right? So now let us move on to velocity time graph, which is much different than displacement time graph. Let us see how. Now let us know about velocity time graph. Here the velocity is on the y-axis and the time is on the x-axis. The unit for velocity is meters per second and the unit for time is seconds. Here the most important thing, the slope of velocity time graph gives us the acceleration for the object. Listen me carefully. The slope of the velocity time graph gives us acceleration, while the distance between the slope and the x-axis gives us the displacement of the body. Now, how can I say that? The displacement of the body covered can be calculated by measuring the area of the graph. The displacement of the body can be measured by calculating the area which is between the slope and the x-axis, whereas the slope signifies acceleration. How to do that? How to calculate that? Let us know. Here I can easily draw a line like this. Now 5 meters per second is the velocity here and the distance is covered in 5 seconds. So change in velocity divided by time gives us our acceleration. So here, what is the final velocity of the object? Final velocity of the object is 5 minus initial velocity of the object. What is the initial velocity of the object? Initial velocity of the object is 0. Okay, 5 minus 0 divided by the time taken. What is the time taken here? The time taken here is 5 seconds. 1 meters per second square is the acceleration here. It's as simple as that. You just need to remember that the slope of velocity time graph gives us acceleration, and the area below the slope and above the x-axis gives us the displacement. Let us see how. Here, if you want to find the displacement here, what you need to do? You need to do half into base into height. Why I am doing half into base into height? Because the shape formed here is of a triangle. If the shape formed was a rectangle, then you need to do length into breadth in order to find the displacement of the body. So half into base into height. What is the base here? We got 6 here. What is the height here? 3 7 3 are 21. 21 meters is the displacement covered by the body, and this graph is not to scale. If it were to scale, then the answer would have been different. But the simple concept here is the slope of the graph gives you the acceleration, and the area which is between the x-axis and the slope of the graph will give you the displacement of the body. Now let us look at the last category of graphs of kinematics, that is the acceleration time graph. And by reaching here, you might have assumed that the slope of the graph, the slope of the acceleration time graph has to signify something. And if you have guessed so, then you are right. Because the slope of acceleration time graph gives us the jerk. What does it give? Jerk. Normally the questions about jerk are not asked in examination, but still it can be asked in the form of fill in the blanks or MCQ. And the area which is between the slope and the x-axis gives us the displacement gives us the velocity which is covered by the object. Okay, so the area between the slope and the x-axis in velocity time graph gives us the displacement, but the area which is formed between the slope and the x-axis in acceleration time graph gives us velocity. Now once again doing a comparison here, the slope of velocity time graph tells us about acceleration, but the slope of acceleration time graph tells us about jerk, and in the same way the slope of displacement time graph tells us about velocity. So I just explained the gist of the chapter in the last 30 seconds. So the motive of this video was just to explain in brief about these three graphs, the main concepts, some examples, how to do calculation. I have explained everything to you, and if you have liked this video, then do subscribe to my YouTube channel. Thank you.